Hi, I'm Fitzroy Gordon. This is my final project for CSCI E90. Today, I'll be going over the Sagemaker canvas, how this works. For introduction, we talk about configuring the prerequisites and how I acquire my dataset, constructing prediction using Sagemaker canvas. I'll also talk about the utilization of the model and how I generate the data that I need, and then I'll create a visualization dashboard using QuickSight. For introduction, I will take a step-by-step approach of creating a stock price prediction without coding, and what this will do is utilize a no-code approach using Amazon SageMaker. I will be taking you through the steps to give you a better understanding from inception to completion. The technology that I'm using will be a NASDAQ download, and this will provide for me a historical data for over 10 years, the maximum amount that I can get from NASDAQ. And then I'll select the stock that I'll be using, but I'll be using the Dow Jones Industrial Average with a ticker symbol of DIA. Then I'll upload that data to a S3 bucket. This will later be accessed using SageMaker for its modeling, and then from SageMaker we'll do a no-code analysis, look on the coding, change it, update it as needed, and then I'll import that into QuickSight to do evaluation of the data. The benefits of using QuickSight is the fact that it can add and remove values from the data to make it more visible and make it more appealing. This is our architectural diagram, and as you can see for the architectural diagram, I'll obtain a historical data set from NASDAQ, as I said earlier. Then I'll modify the data set, upload it back into S3 bucket. Then I'll use SageMaker Canvas to build the model and visualize it for further cleaning. And this is where you see that iteration within the model. If that is needed, we send it back into S3 and re-upload it data if we need further classification or further breaking down of the data. Finally, we'll visualize the forecasted data using QuickSight for better review and better manipulation of the data set. The data model, as I said earlier, is coming from NASDAQ.com, and this will include holidays and pricing. The SageMaker Canvas uses information in the dataset which views up to 250 models, and it chooses the best one that can perform for your use case. Using Amazon SageMaker, we'll build, train, and deploy, and what we will focus on in the model is also analyze and predict what we need from the data to give the best chance of doing a purchase of a stock. We will cross and visualization, as I said earlier, and we'll do that in QuickSight. So here we have a demo of what we'll be doing. First, we will download the data set. We have already done so using the Dow Jones Industrial Average, and here we have a copy of it. This is the maximum year, which is 10 years, which gives us about 3,000 data points. This column here was not there before. I actually added this so that I can have a unique value, and for the Canvas database to be able to manipulate the data on a unique value across the spectrum. And we have the date, we have close price, open price, volume, high and low as well on that data. Next, we download that. We then have provisioned our S3 bucket, and in provisioning the S3 bucket within SageMaker, you will notice that it created two unique S3 buckets. One that is applicable for my use is SageMaker US East 1, and the US East 1 is the one that we'll be using. That's where we uploaded our database. So let us go straight into the demo for this. So here we are in Amazon SageMaker, and what we do, we open Canvas with a default status. This takes 20 minutes to actually get deployed, so we'll go straight ahead, and we have provisioned that here already. Initially, the first step you need to make is to go into Data Wrangler, and in Data Wrangler we'll have some sample data sets, but we have uploaded two data sets, the data pricing model and the DIA model. And in uploading two data sets, what we're going to do, we're going to create two data sets from scratch, right? So we're going to select create to the right, then we're going to use a tabular form, then we're going to name our data set. So we call this DIA present / predict. That is our data set. We'll now create that. Then we create and we upload that to Amazon S3, or we can upload that from our local computer. We can also use Snowflake and Redshift and any SQL database as well, or Athena. But we'll use S3 today for that data. And if you notice, it's integrated with my S3 bucket, those two that I pointed out earlier, USS East 1. But what I did for this assignment's sake, and based on the architectural diagram, I actually created one fresh, so show that you do not need the one that was provisioned from Sagemaker, but you can actually create an independent bucket. So we created that, we uploaded our historical data as we pointed out later, and we had extended that. Of course, remember we add that column that is called DIA. This is us showing that we can make changes to the initial data. So we'll now import that and create a data set. What you will see here is that it creates an initial 100 first previewing row, and it's just showing you what the data look like now, right? 100 rows. So we will create the data set from this, and as we go along we may have to pause the video from time to time because each one of these take some time to actually create. So in this case it creates what we call present predict. That's what we want to use. We select that. Next we select present predict. We click on that, and hopefully, yeah, it gave us the option now to create the model. So this is our next step. So we're going to create the model, and we'll use predictive analysis because we're trying to predict something in the future. So let's call this DIA. I'll call it set 2 because I do have another one there. So DIA set 2. I select create, and it will create the model on my behalf. At this point, I will attempt to pause the video and have that create. It will take about 50 minutes. Okay, so we can now resume. That was completed. The model was set up for DIA set 2, what we have just created. And if you notice, it unchecked our ticker symbol because it is saying this is repeated across the spectrum, so it's not useful. However, we need it to have that unique value so that we can use it. It is saying SageMaker recommends dropping the column. It has a large number of unique values which might not help them building the model, but we're going to include that. We're going to keep it. We need it. And our target column, in this case, we use closing price. Why closing price? Closing price will give us the opportunity to get a data set that can actually look on a point and build the model on that point. Next, if you notice, we have a range or value distribution from lowest to highest price across the spectrum from 153 to 357 over the 10-year period. Then now we have to configure the model. So in configuring the model, we'll select that unique value we spoke about. That was what? Ticker symbol. Next, we select date. We keep date because we're going to do this on a 30-day plane. So we select 30 date. Then we include holiday schedule. So US holidays. And here we'll select our country. What country are we in? I believe we're in the United States of America. And in the United States of America, we select save. And while that is saving, we would also want to share that although it doesn't have fundamentals in it like political events, this model will take into consideration the US holidays, which is pretty unique from this Canvas SageMaker thing. This is not normally able to be done in an Excel environment, so this is one of the benefits of using this ML, right? So now we see that we have volume as future volumes represented here as future volumes. We also see that ticker here is showing as an item ID, meaning that it is using ticker to help us calculate the data and to better assimilate the data. And you see that date, if you scroll down, it takes date as a timestamp. We also can transform this data, but we will not make that changes today. So these are some of the different areas. So we see the closing price is our target. We want to see what the closing price is, right? So now that we have this, we can now build the model. We have the option to do a standard build, or we can do a quick build. A standard build takes quite a while, but it is more accurate in our data modeling presentation. But for the sake of time, we will use the quick build. The quick build will take about 50 minutes to build. So I will click on quick build, and while it's I'll change this back to quick build. And then quick build. While it's validating the data, I'll then pause the recording again because this can take 15 to 20 minutes. So I'll go ahead and pause the video. So as we can see, it's actually analyzing the data, just doing a quick transitory review. And as we can see, it is taking 14 to 20 minutes for the build time. This is quick build, and what it is doing now, it is training the model. If this was a standard build, it will take about 2 hours. So I'll now go ahead, drink some tea, drink some coffee, and I'll get back when this is done. Okay, so that took over 20 minutes to run. And as we can see with the data points, volume is the main ICE predictor of all the model will be affected, and that is followed by high in terms of the high versus low prices. So when we get this volume and this model, we see that there are a few model statuses, right? I will see at the top with MAP, WAP. These are actually weighted averages that are used to help with the calculation for accuracy, and these are normally associated with what we call performance series index. So that is what those WAP, MAP stand for. So at this point now we can go to predict. We hit the predict button here to start making predictions to the model, and then after that we go one, select single prediction. We choose an item to work with. We will choose DIA, and then the prediction starts at work. So while that is working, you will see that the DIA here that is selected, it starts with an early date and then go all the way for a 30-day period. This goes up until December 31st, 2023, and today's date being the 13th. So along this line, we see a different prediction from the one we see in a previous assignment, and it's actually recalculating. Now, one of the points I want to point out, if you notice, there are some zeros here in intervals. These relate to weekend. So the model knows that on weekend there are no trading and there are no trading days, so there are no volume to show here. Another thing that I like to point out is a P10, P50, P90 in the legend. And what this P10, P50, and P90 represent is the highs, lows, the buys, and the sell. And those are represented to show the model that we have a lower bound for buy, a P50 for forecast to evaluate the prices, and then a P90, which is the upper bound to sell. Those are what those represents. Next, we download this prediction by clicking download here. We can download it as a CSV file, and we have done that, and this gives us the single prediction result file. And the single prediction result file, I'll open that. This is what that looks like. We'll be reusing this later for our other statistical piece, which is in QuickSight. We have done that already, so we don't need to redo that. So we now have build, analyze, and predict. We have our model in front of us. We can move across the different timelines and see what that represents. So our next step is to now move over to our QuickSight database. So here we are. We've logged into QuickSight, and we are seen here with the dashboard. So what we're going to do, we will create a new data set, and the new data set will upload the file that is the file we just showed. We can also integrate this with S3, where it pulls from S3, where you could have a rehashing of the value or a reintegration of the value, but we upload from a file and we select the single prediction results, right? I'll cancel that because we have done that already. And then we cancel that. Next, we have our single prediction value now being uploaded, single prediction results, CSV file, and then we put the dates in. So let's do that. So we're going to put the date as one of the X for the X axis. So our dates are aligned. That looks good. Then we put a lower bound, and the middle bound, and then upper bound. And just like that, we have our variation, which is pretty similar to what we're seeing in our model in Sage, right, in Canvas. But the difference with this, as you can see, we have updated. We have now called it stock predictor. We have our volume. We have our trading here. The difference with this, we can play around with this model and we can create different data sets based on what is needed for the person that we're creating this for. And this is the benefit of this. In this scenario, what this is saying, and I will just add back our original line chart, putting back these data. And what we can do here is this. We can do an estimation of the purchases. We can do an estimation of the purchases, and it will look something like this here. So let's do this estimation of the purchases. All right, and what this estimation of purchases is saying is this. We have a scenario where we have a lower buy price we see from the stock chart, and if we buy at say 254.73 in this scenario, we'll use the date, let's use December 13th, 254.73. And if we buy at 254.73 and we move up to December 20th, we now sell at 353.98. What is the difference in prices if we take that future prediction? So I put it here, do a little calculation, and we assume we buy at 254 as we discussed, sell at 353, and we're purchasing 100 shares. What that will give us is the ability for 7 days to make our loss or profit. So we put that in, we put in those data, 253 minus 398, it came to $99.25. We bought 100 shares. Let's assume all things being equal, we sell that at 100 shares. We make $9,925 in 7 days with this profit. So that is the benefit of that. Other things we can do that we spoke about earlier, and why we use in QuickSight, is that we can remove the weekends by doing an aggregation, removing aggregation from the whole total itself by editing the visual. But that not being a part of the question, changing the visual arts, changing the data is some of the things that we want to do. So if you have any questions from this assignment, this sums it up. If you have any questions, reach out to me, let me know, and I will answer them. Thank you for viewing this, and I look forward to hear from you. Have a good day.